welcome back to Mailbag. Ta-da! Haven't had anything come in for a long time. Getting excited. Right, let's open the box. Stuffed full of bubble wrap, and I'll whip that out. That might have personal information, and oh, I don't know where this air was put in. There's one lot of air gone. Right, what's in the box? We have, oh, reasonably heavy. No idea how good these are. Prolec Ultra alkaline batteries. But they're just cheapo. Focusing is annoying, isn't it? Jumping around. Let's do something about it. Right, that's it. Focus locked. So 40 batteries for about £7, I think. £6, £7. So cheap. And then of course you have to buy things to get it up to £17 to get free postage. So I added a reamer, a tapered reamer, as it's a sort of a reasonable thing for opening up a few holes. And I've not got one, and it was about £7 as well, so it wasn't that much. And then we come to some interesting things. See that there? SN74 AHCT1G08 BDVR. Now, little get some light on it. What happens if we try a little 5-pin chips, and they are 2 input AND gates. So if you look that up, maybe I'll put a link in the dibbly-doo, but you know, just look up the part number, and you'll find out what they are. They're for an up-and-coming project, and these little tiny things. I should really use the microscope camera, shouldn't I? Right, let's just get the microscope camera in. Why not? I can hold it in my hand. Well, I thought as part of the post bag we'd have a quick look at the data sheet for the SN74 HCT1G08 single 2 input positive AND gate. See there, positive, it's an AND gate. It's not an OR gate or an OR gate, they're positive, it's an AND gate. That's what I can get from that. And it's got the usual sort of TTL type voltages, 4.5 to 5.5. Reasonably fast, 7.1 nanoseconds. Low power consumption when it's not driving 8 milliamps out of its output. And the inputs are TTL voltage compatible, which is good. Yeah. I don't know how often they're going to latch up. but it's got reasonable reasonable performance if it latches up. And there's all the things they'll put it in. It's glue logic basically. It's like, you know, if you've got a quad 4 input, if you've got a quad 2 input NAND gate and you need 5, then what do? Do you get another package of 4 or 3 and only use one of them, or do you just buy one of these little tiny slot 203 devices and just stick the extra one you want in? And sometimes you may only want the one, which means it still saves you having to waste another 3. And then this is, I really should work out how to make my mouse pointer a bit better. But under the description, this bit here, the device performs the Boolean function y equals a dot b, or y equals a plus b underscore, oh sorry, overscore, in positive logic. So they're positive, it's logic. And that just made me laugh. I haven't looked at Boolean logic for ages and ages and ages. So I just sort of thought, well, we'll have a look what they are. And there's the dot, and the dot means and the plus is an or. So if you negate the plus with a bar, you get a nor. So then I thought, well, let's have a look down here. So we got a dot b equals y. We make that 1 bar. And then we got a plus b all barred equals y. And then if we go down for the truth table, if you think about it, these are not a. So if a's a 0, here a's a 1. Same with b. They're the not value of this side. And if you think of what an OR would do, an OR, if either one or the other is true, the output is true. But it's a NOR, so it's not. So if either they're true, the output is false. And with an AND, you've got to have both true to get an output that's true. And so we go through the logic. 1 0 0 1, outputs of 0. 0 1 1 0, output of 0. Then we get to 1 1 and we get an AND, so we get an output of 1, which is true, and on the NOR 8 we get 0 0, which gives us an output of 1. So as you can see, that function of not A, not OR, not B equals Y is exactly the same as A and B. So why they bother to tell you it twice in 2 different ways, I don't know. But I just thought that was interesting. You know, I haven't thought about Boolean logic for such a long time. And there's a diagram. Pin 1 and 2 are inputs. Pin 4 is the output. So that leaves me as 3 and 5 must be the supply. Maybe it will tell you if we go further down. Get through the table of dibbly-doo. Well, there we go. AB, ground, VCC, and output. Now look, if you can't look at the picture, you can read it here. Specifications, absolute maximums. Absolute maximums, you will bugger it if you go above 7. Bring it bluntly. And what currents it can get and what temperature. That's pretty good, 150 degrees. Minus 65 for storage. Doesn't give a minimum temperature for operation. Maybe it's not on that page. Oh look, ESD. Plus or minus 2.5 kV for the human body model. And for the charged device model, 1000 volts plus or minus. Easily do that. You can easily generate those sort of voltages by walking across the carpet. Right, recommended 4.5, 5.5 supply. input level low for a high output is 2. Maximum low level input voltage is 0.8. Above that, it's into the uncertainty region. Output voltage, or input voltage 0 to 5.5. I suppose 5.5 is if you've got a 5.5 supply. Going a volt above it if you've got 4.5 in. If it's got protection diodes, ESD diodes on the input, then there's a chance you will try and drive the supply up by passing current through the diode. As there is one. So there we go. It can sink. Does that sink a bit? Source a bit of current. Sink a bit of current. A rise time of 20 nanoseconds per volt. I think we're testing that. Oh, operating -40 plus 125. That's probably extended industrial, I think. I can't remember. It's a long time since I've had to look at all these component these operating conditions and work out whether they work or not. I know military was -55. I thought industrial was like -20 and extended industrial was -40, but I could be wrong. It's such a while since I played with it. And it will get warm. And a few of the more characteristics that you might want to know about at different voltages and different temperatures, and how much capacitance it can switch. It's all good fun, isn't it, if you read these things? What's this? I don't know. Nanoseconds versus temperature, so it gets slower as it gets hotter. Or is it faster as it gets hotter? I don't know. I haven't really got a good read of it. I just thought I'd have a look through. Look, waveforms. Wonderful, eh? So, there we go. Gone through it a bit fast, but if you want to have a quick read, just go on the TI website and download the datasheet. Well, just search for that part. The datasheet's everywhere. It's not difficult to find, so I won't bother putting it in the dibbly-doo down below. So that's the datasheet on that component. These are little 4-pinned jobbies. So that was exciting, wasn't it? Get rid of that. And these are 2-input. Well, so it's 2-input. They're FETs with 2 gates. So they're a dual gate FET. And the idea is you can put a signal through one gate and a control voltage through the other gate, and you can make a sort of voltage controlled amplifier. That's the idea. And so I was just making up money, and I saw them and I thought they're interesting. Not played with them before, so there may be a video on them. This is the data sheet for the little Mosfets that I got. So they're for low noise, gain controlled input stages up to 1 GHz. I've never used dual gate FETs. I'm starting to have a play with some RF stuff, which I might do a video on at some point. I bought one out and bought a load of ferrites and some mixers and things, so I might have a go at making a little radio. And when I saw these, I just thought, never used them before. Lots of the radios I've got have got dual gate FETs in for gain control, so I thought, well, if they've done it, I'll have a quick look. And so, some people might know more about this than I do. Normally I look for like the voltage for the gate. Was it the VGS-TH, the threshold for the gate, whereas this is referring to something as the source pinch-off voltage, which possibly is the same as the gate threshold voltage. But a lot more investigation. And again, if you put the part number into the web or the CPC number and go onto the CPC Farnell website, there's a data sheet there, dead easy to get to, so I'm not going to put a link to it. As it's, I suppose, used for RF, all the important things are what its capacitances are and power gains and that, noise figures, all the usual things. But, There obviously is a difference in the performance of the gates and the construction, so slightly different graphs. But you know, I've not used it yet. I'm going to have a play, so this is just fun. So there we go, all the little packaging details. And if you make your own PCBs, there's the important bit. And you want to know your footprints right. Nearly all the components on the data sheet, they will give you the correct footprint layout for your device. So that's where you want to go and check. That is, unless you buy it from China, and they probably don't care if the package is the right shape. I don't know. But there you have it. There's the data sheet for the BF998 series. So I hope you found that bit interesting. So that's the box. Something else arrived, but it didn't come in a box. Ow. Oh, I'm going to take that one out. I fell off my chair. Ah! Oh, that's buggered. Did I break anything? No. Huh. Should I keep that in? I fell off the chair lifting it up. So 100 meters of cable. I got this one cheap because it was surplus to their requirements. Right. Oh, it's all loose now. That's PVC shield screen. Then we have an aluminium foil outer screen. We have a screen wire, and we have two more screens, which it looks like could be isolated from each other with a piece of clear wrap. And then there's another screen wire conductor wrapped around the foil, and then we take the foil off and we have a red and black. And on this side another screened wire, or not a screened wire, but a wire for the screen to give a good conduction to the copper foil. And then we have white and green. Now this, I expect, is Ethernet cable, and very well screened Ethernet cable, and I'm going to be using it on another project. You've seen parts 1 and part 2. This will be in the next. This will be in the final part, because this is the power and control. It will be the power and the control signals. So that was a really good buy. It was very cheap. I think I paid £8 for 100 meters. So these bit dark, isn't it? Have a light on. Problems with reflections. I can't find a good light. So these are today's items. So like, hit the notification bell, subscribe, help remember the channel. Ha. And yeah, hit the subscribe button. I might put a little thing up there just to point out that 80% of the channel viewers aren't subscribers. Now, if that 80% subscribed, didn't bother to click the notification button, then I could get to 1,000 viewers, which would be great. So if you're not a subscriber and you want to subscribe but don't want to watch too many of my videos, don't click the notification button, and then when I get to 1,500, unsubscribe. How's that? Doesn't cost you anything. It'll help me tremendously. So just subscribe, and then cancel when I get to 1,500, and I don't need them anymore. But that would be great. How's that? Bit of sub begging. Catch you on the next one.